Morning, everyone, and welcome to our third and final day of Industrial Ethernet Week by Harding. Thank you for joining us. This week, we have explored the market surrounding industrial Ethernet, what's driving the growth, how it's becoming prominent communication protocol, how it relates to legacy protocols, and most importantly, how end users can benefit from industrial Ethernet. Yesterday, we discussed the technology side of the market and how to select the right Ethernet technology for your application. We also explored how industry megatrends such as miniaturization are impacting the roadmaps of technology. Today is our last and final session focused on single-pair Ethernet and its emerging role in industrial applications. You can look forward to learning not only what is Harding doing in the world of single-pair Ethernet, but also the proactive steps our partners from Worth and Analog Devices are taking to support the market as they begin implementing the technology into the next generation of product designs. You'll also hear the perspective of both Rockwell Automation and Harding as we discuss the future of Ethernet technology. At any point in time during the session, if you have questions or comments, please feel free to drop them into the chat box and we'll use them for our Q&A session at the end. I'd like to start us off today by introducing our host, our technology manager for standard development, Mackenzie Reed.
Good day, everyone. Thank you, Casey. So I'm going to quickly move through just an introduction to what Harding is doing in the world of Ethernet and single-pair Ethernet specifically, because I want to give as much time as possible for our great panel discussions with our guests. So single-pair Ethernet. If you joined either one of our single-pair Ethernet symposiums or any of our webinars dedicated to this subject, you're pretty well versed in the Harding portfolio of products and what we're doing in the world of SPE. Today, we're going to take that into the next stage where we're going to start delving into the different flavors of SPE and how this full ecosystem really works. One of those flavors is APL, or Advanced Physical Layer, that you'll be hearing about. The other is resource-constrained in-cabinet devices, which you'll also be hearing about. And I will be covering both point-to-point general-purpose SPE as well as hybrid single-pair Ethernet in this introductory session. So you can see that the connector portion of this SPE ecosystem is currently illuminated in yellow. We will also be hearing from Würth Electronics on the magnetics and ADI on the semiconductor portion during panel discussion 1. So what is single-pair Ethernet as opposed to standard Ethernet? So if you're familiar with fast Ethernet up to 100 megabit per second, that's typically 4 wires or 2 twisted pairs with transmit or receive, as you can see here. When you move into gigabit Ethernet, you're talking about from 250 megabits up to 2.5 gigabit or multi-gigabit speed, where you have a total of 8 wires, 4 twisted pairs that transmit and receive. Single pair Ethernet is exactly what it sounds like, a single twisted pair that both transmits and receives, starting at 10 megabit per second and moving into gigabit and eventually multi-gigabit speed. So you'll be seeing different versions of this pyramid throughout the presentation. This is what is considered the industrial communication hierarchy as of today, starting with the cloud, then down to the supervisory or main control center. Then you go down to the third level, the controller PLC layer, where maybe we're focusing on one individual cabinet enclosure. And then finally down to the bottom, the field devices, which are physically mounted in field applications in manufacturing zones. As we move into Industry 4.0, we expect to see a certain shift in how we look at this hierarchy, mainly because, as I'll show in an example, going from sensor to cloud is now completely possible. And not only will there be bidirectional communication, but we're really going to be realizing the vision of IoT with smart field devices eventually beginning to communicate directly with each other. So key market dynamics as to why single-pair Ethernet is so important. Firstly, it's the surging demand for IoT. This buzzword has been used in the industry for close to a decade now, and truly, especially when you're talking about brownfield applications, we're still not seeing the full connected enterprise and manufacturing location. We're still not seeing the full legacy devices and legacy machinery being brought online and harvesting data from these old devices or legacy ones in the field. Single-pair Ethernet will facilitate some of that. Also, we're all familiar with some of the struggles we've had in the last 2 years, both with supply chain and facing a global pandemic. As soon as we entered into those struggles, the need for automation became even more prevalent. Just-in-time manufacturing has its strengths and it also has its weaknesses. And as we move forward, both because of the retirement of the previous generation and their expertise skill set that was covered on day one by Nazario, as well as the need for more increased automation for redundancy and risk mitigation, we see a big need for automation now more than ever. Also, there's a rising demand for modular machinery. So now that we're going to begin harvesting this data, we can make smarter decisions about where machines should be placed, even down to changing it maybe every year if that's what your manufacturing practice dictates. So we need these modular machines to be ready, connected, and able to be moved around as the data presents itself and as we're able to make smarter decisions. And finally, as covered on day one, there is an emergence of miniaturization. All of our devices are only getting smaller, and we're only trying to pump more functionality into them for a lower cost. Single pair Ethernet will facilitate this. And we have the data to back that up. This is not just speculation. As Nazario showed on day one, this was the market landscape as of 2016 of industrial networks, and we've seen that flip as of 2021 with market dominance of industrial Ethernet. I would like to point out that this is before the proliferation of single pair Ethernet, because as you may know, the first component products, such as the connectors from Harting, were just starting to be released in 2020. So these numbers do not yet reflect single pair Ethernet devices hitting the market, which we expect will continue to grow the industrial Ethernet market. Some further data here. Working with a consultancy group and getting an industry report as of extremely recently, you can see the market dynamics globally. So we're expecting close to a 10% compound annual growth rate across the world, starting in 2020 and through 2028, which shows impressive numbers. And I'd like you to keep in mind that these are just numbers dedicated to single pair Ethernet and not the global industrial Ethernet market, which we anticipate will be closer to a $70 billion market. These numbers just reflect SPE, which is pretty impressive. And now what does that mean? How do we realize the vision of single pair Ethernet? How do we get to realizing the true vision of IIoT, of both legacy and next generation devices being on one cohesive network? And what we need with that is standards. I'd like to introduce you, if you haven't seen it before, to the T1 Industrial family of products, also called IEC 63171-6. You're going to be hearing me say that term a few times throughout the presentation. The T1 Industrial is the product name, but the 63171-6 is how it is recognized by the standards organizations like IEC and others that I'll be going through. So I'd like to highlight some of the projects where the 63171-6 connector is already specified, starting with TIA TR42 for industrial applications, as well as IEC SC25 Working Group 3 that also chose this as the industrial connector of choice. And the one that most people know, which is IEEE 802.3CG, which you can see here. I would like to draw a distinction of the differences here because the CG project is specifically focused on 10 megabit per second applications. And this is the one that we may be focusing on most today. It's the most disruptive. It's the one that everyone is the most excited about. The 802.3 project also covers these other speeds and distances, but again, this is the one that has everyone most excited today. So that was a very brief look at standard T1 Industrial. And I say standard because it uses two wires and we're able to communicate power over those two wires. Now that power has limitations. This power is called power over data line, or single pair power over Ethernet. But what if you need increased power that exceeds what you're able to do by using just the single twisted pair? You need dedicated power pins, and that is where single pair Ethernet hybrid comes into play. The first connector I'm going to show here is the 63171-6 hybrid. And we're actually going to bring this down onto the floor here, and I'm going to explain a little bit of what it is. So what you're looking at here that I'm going to be trying to manipulate is you can see the wider diameter two pins that are rotating towards me right now. Those are the power pins. Those are dedicated for power transmission. And the two that are further away from me are the signal pins, the data single pair Ethernet pins. So you can see that there's a total of 4 wires. And that is why this is considered a hybrid connector, but it still falls into the -6 moniker. So some details about that is that it is an M8 screw locking mechanism, and that's going to be important when I talk about the next connector. Also, as I said, you're able to transmit power over 2 contacts as well as data over 2 dedicated contacts. So power is broken out instead of using PODL technology. It's also fitting inside IP65 and IP67 industrial housings, which is very important for field applications down at the sensor and actuator level. And finally, as we've specified before, it's ready for higher power delivery. This is especially important when you start looking at the new -7 solution. So the -6 hybrid has a total of 4 pins. This is one of the first generations of the -7 in an M12 form factor. That's the important distinction here, is that the -6 goes inside an M8, the -7 goes inside an M12. And as you can see, there's 4 dedicated power pins for higher power transmission, as well as the 2 standardized single pair Ethernet pins that you can see here. There are multiple designs in the works with different pinouts depending on what power you require. So what's the main difference here? Standard single pair Ethernet using power over data line technology, whereas the hybrid has 2 dedicated power pins, or in the -7 it has multiple dedicated power pins. This is important because PODL is currently limited to 50 watts, whereas the current generation of the -6 hybrid is rated for up to 200 watts of power transmission. And finally, as you move into the different flavors of SPE that we're going to be talking about, I'm going to show an example of a multi-drop solution, which is actually a physical T-drop solution using this hybrid. And we're also going to cover the multi-drop or resource-constrained solution, which is an inline solution. So the hybrid use case, just very quickly, you've seen this slide before of the transition of the industrial Ethernet hierarchy. These are some of the components that make up this hybrid solution that I'm about to talk about, but it truly shows that you have an end-to-end hybrid single pair Ethernet solution that's available today. So starting with the Wi-Fi router, it connects to either the Peri-Mica or the Peri switch, goes into these T-drops that I was just talking about. Then it comes down into this M8 housing on one side of this adapter, and on the other side is an M12A code that allows you to adapt to any sensor that uses an M12A code that's currently being sold either by your manufacturer or through distribution today. And I really want to emphasize that point because single pair Ethernet hybrid is available today, and people, I can speak confidently, are already using this technology from our partner PeriNet, where Harting was very instrumental in the single pair Ethernet hybrid design. So again, you're going directly from a router all the way down to an individual M12A code sensor in the field today. All right, so I moved through that very briefly. Again, I want to give us as much time as possible for our panel discussion. So I'm going to invite our first 2 panelists, Fareed from Worth Electronics and Fiona from Analog Devices, to join me for our panel. Welcome.
Thank you.
Thanks for the
So I guess
All right. So we're just going to do a quick set change here. Just give us one moment. And through the magic of technology, we're back. All right, so welcome to our panelists. I want to dive right into it, starting with our first question of the panel discussion. So from both of your perspectives, what does single pair Ethernet mean within your organization?
Yes, so I guess, do you want to start with me? I'm Fiona, I'm from Analog Devices, and I lead our marketing effort for industrial automation. So I guess when we look at single pair Ethernet technology, I suppose for us, we've been working with our customers over the last number of years, and it's really what we see. It's about making seamless connectivity, which you started with your presentation, and making every node in our factories or our buildings or our cabinets, making them directly addressable, configurable, reconfigurable, so that we can actually interrogate them in real time. And this brings about, a whole host of new data that's now available in our central control systems. And that means that we can optimize our productivity, our processes, our buildings to make them more efficient, to make them more sustainable. So it's all about what we see as a barrier-free networking, and that you have direct IP addressability so that you can, interrogate all of these assets in real time. And I suppose for us, really great thing is about running over these, single twisted pair cables, which you mentioned. They're lighter, they're more malleable, so it enables a certain amount of retrofitting to upgrade plants, but it also ultimately simplifies that overall communication network. And then when we think about, that seamless connectivity from the edge to the cloud, and we bring onto that, TSN and ADI some capabilities around TSN, that whole IT-OT convergence opens up that whole seamless data transfer and synchronization down to the edge nodes. So that's some of the awakening new applications and new insights for our customers. And that's some of the things that ADI has been seeing over the last number of years.
Perfect. Fareed, I'd like to hear from you as well of what it means to your organization, and then I'll touch on a couple points myself.
Thanks, Mackenzie. So, hi everyone. I'm Fareed. I'm an applications engineer for Woods Electronics. If I want to summarize it, man, it's innovation through simplification. SPE is a simpler, more capable communication platform that is trying to address the tangled web of field bus communications that was the go-to for all the industrial automation approaches. Now we are taking all that away, replace it with a single pair wire that is IP protocol, and each sensor, each node, actuator, encoder, you name it, can directly talk to the cloud and provide its data. That helps with doing a lot more with a lot less effort, hence increasing our throughput, and also simplifies the footprint. It reduces power consumption, maintenance costs. All that are the benefits that we see with SPE.
Perfect. And, Fiona, you made a point there that I'd like to draw on further, which is the convergence of IT and OT. We're seeing that both within our organization here at Harding, as well as the standards organizations that I sit within, some of the ones that I presented, as well as ODVA. That is a constant point of discussion, is the emergence of IT and OT, making sure that they don't bump into each other, that they are working cohesively together, that we're setting standards and choosing the right products and devices for the right environments. And we'll dig into that a little bit more as our discussions continue. But I think that is one of the major points here is convergence and efficiency, which we'll speak to a little bit further. But moving along, Fareed, I think I'll start with you, and we'll pull up the slide again. But what is needed by OEMs in the different industrial markets, whether that's industrial automation, machinery, agriculture, really anything, to implement single pair Ethernet technology?
Yeah, thanks, Mackenzie. But that's a great question. So let's consider the Ethernet as a system, like any Ethernet. Each system in Ethernet world has three main components, right? Previous. So first of all, you need a physical layer controller, a 5 factory, right? And for that, you also need magnetics and connectivity. These are the three main components of each Ethernet, regardless of which IEEE standard we're talking about. At first, you would need to select a PHY that satisfies your needs, all the capabilities, features, and all that. And from there, you would select the connectivity and magnetics around it. Now, today, can we design an SPE Well, the short answer is yes. Right in this slide, we can see that there are PHYs available from ADI. We have the magnetics covered, and you guys are doing a great job with the connectivity part of the equation. The thing is that the SPE standard, the 10 base T, which is the most important and exciting right now in the market, was only released in 2019 by Entropy, and the PHYs have been in the market for about a year now, right? I'm right, Fiona?
Yeah.
With all these components that are available today, you can have an up and running 10 base T solution. Let's not forget that it's either you're going to update the design or start it from scratch at the board level, but also infrastructure needs updating as well to accommodate for this new technology to be implemented. Now, another phenomenon that we do have in Ethernet, we used to call it power over Ethernet, PoE, or PUDO as we have it for SPE, is also available in terms of technology. However, controllers are becoming available more and more, and we are expecting to see end solutions from that regards of the PUDO for the controllers. I'm sure Fiona has a few to show us or talk about it with us. Today, as we stand from the magnetics point of view, we can deliver up to 60 watts with a simple 1090 package coupled inductor.
Perfect. And Fiona, I'd like to hear your take as well from ADI standpoint of what's needed today or anything you're thinking.
So I guess if I just take it up a little bit to the architecture level that, in a factory, for example, to deploy this and to make it useful really in any facility or any enterprise, you need all of the layers that you spoke about in your triangle at the start. So you need the devices, which are SPE enabled or 10 base T1L. So things like field instrument, field transmitters, pressure instruments, temperature sensors. And then you need the actual control layer above, or your data aggregation layer, so like a field switch type layer, and then up to your PLCs and your more control layers and onto your cloud. So what we've been seeing is, and we've been working with customers at all of the different layers to ensure that, we have that they're enabling them to bring to market end devices that can interconnect. So we're talking about field devices at the device level, but also at the field switch level, because we need those aggregation points, and then standard Ethernet, like gigabit Ethernet, up to, let's say, our PLCs. So you can see last year, a number of customers actually brought 10 base T1L field switches they launched them during the summer last year, and other vendors have come on stream since. And people are bringing to market now as well and sampling actual field devices. So we have customers who are making actual test beds, and they're actually deploying these as networks, and they're actually experiencing the benefits that we talked about on the previous question in terms of access to all of these new data, access to new insights so they can make more informed decision making, faster commissioning, reduced maintenance, faster fault detection. So for me, it's making sure that all of the different layers of the network are available so that people can actually deploy a full system. And once they experience the true benefits of Ethernet connectivity and seamless connectivity, then it's really going to drive the market forward.
So, okay, we've convinced the audience of what they need to do and some of the reasons why they should begin looking at single pair Ethernet. So they begin doing research and they get online and they see a lot of talk about 10 base T1L and Ethernet APL. Sometimes both those terms are used together. Sometimes those terms are used separately. So Fiona, for the audience, I know that there's some discrepancy there, and we want to make crystal clear what these two technologies are and how they complement each other. So could you dive into that, please?
Yeah, and I guess in the Ethernet world, we do love the acronyms and the buzzwords.
We should.
To make everybody's life easy. But I guess when we talk about 10 base T1L, really it's a physical layer standard, and it's that you put up that nice graph there that shows the IEEE 802.3 CG, and it really fits in there. And 10 meaning 10 megabits. And the really important thing here is obviously single pair, right? That's the media, but the 1 kilometer. So it's L. L means long. And what that opens up is that ability to provide Ethernet over much longer reach than we could previously do. And that's what's really transformative, because now devices that were once quite remote are very, in buildings, if you wanted to get between floors or elevators or big factories or process environments,
Sure.
we can now take that Ethernet over that longer reach of a kilometer. And in fact, a lot of the products like our Phi and our Mac Phi actually go beyond that. They can go up to 1.7 kilometers. But really, I think everyone has to really design for the standards. You are really bound by the kilometer. And then Ethernet APL is like a layer on top. And it's where vendors from the process automation industry came together to use 10x2NL in their specific use case of hazardous area environments, which are process control environments, or we call it intrinsically safe applications. And there's very stringent requirements on power consumption. So the 10x2NL was specifically targeting those applications in terms of being very, very power efficient. So you're talking about 39 milliwatts for one of these PHYs. You're talking about a little bit extra for a Mac Phi. But what's really nice on the Mac Phi side, and we find a lot of our APL members, go in that direction, particularly for the devices, because you get Ethernet with an SPI interface, and you can post it or pair it with any host control processor, and then you can actually have a really optimized system from a power perspective. And then that's also enabling them to do more at the device level. So if they have now more bandwidth, they can take more measurements, they can transmit more data, they can use higher precision sigma delta converters, let's say, from ADI. They can get multiple different types of measurements, and they can do that kind of sensor fusion. So we're talking about that real intelligent edge now. And now they've got that bandwidth, the 10 megabits, and they've got the reach over which they can transmit it. So I think they're complementary, really, but one is very specific to our process environment.
Yeah, it's really incredible from the power standpoint that, really for the first time, we're safely bringing power into these intrinsically safe environments, not only in the same wire as the data communication, but also to the speed and distance that we're talking about. It's a really substantial improvement. I think that people are still maybe wrapping their head around how big of a deal this is, but if you're someone in process automation that's been designing for these environments, they're already very well aware of how significant this is, because it's going to unlock a lot of capabilities for them. So Fareed, I want the next question to go to you, which is standard 8-wire Ethernet is something that's been established for a very long time. People are very familiar with it. From a magnetic standpoint, what is the difference between 8-wire Ethernet and single pair Ethernet?
Yeah, thanks, Mackenzie. Another great one. So the conventional 4-pair or 4-channel or 8-wire Ethernet is using 4 LAN transformers, single LAN transformers, and 4 common mode chokes as per the standard by the IEEE dictation of the parameters. In one of them, for example, is the isolation of 1.5 kilovolts. That we achieve that through the LAN transformer. Also, some insertion loss, return loss, crosstalk, and parameters like that you require to have that common mode choke there for every single channel. Now, if you bring in the mix the PoE, we also need to accommodate the power through each channel on the magnetics, and they are to take the blame for that power as well. Comparing that to a single pair, you are reducing the 4 channels to 1. So instead of 4 LAN transformers and 4 common mode chokes, you are going to be using only 1 of each. That is the main difference and benefit. Also, at the same time, if you are looking at, the 9 amp, 10 amp at 60 volts, 600 watt LAN power transformer that we can supply in an EFD20 package, we can do the same thing with a coupled inductor in a, again, 1090 package in low conversion. Also, when you are traversing in towards higher speeds and higher powers, the size of these LAN transformers and common mode chokes are in the conventional Ethernet are growing exponentially because first of all, they're hand-wound. Second of all, higher speed and higher power requires bigger cores, ring cores that initially was very used. Whereas compared to single pair Ethernet, we are using proprietary chemical recipe for the core material. It's not a ring core anymore. It has its own proprietary shape. And also, instead of hand winding, we are using robotic solutions. This helps us to control the tolerances very well. All that helps us not to increase the size of the LAN transformer when we are going towards higher speeds. And the common mode choke is only one, so the increase in size is going to be linear instead of exponential of 4 pulse.
Perfect.
I hope that answers that.
So Fareed, I want to stay with you for a moment, just kind of touching on that, because we're going to go into, we've covered the differences both of 8-wire and single pair. We've covered the differences of 10BASE-T1L and Ethernet APL. We've told the audience, what they need to do to implement this technology. So we'll pull up your additional slide here that shows the products that you have available to accomplish this now.
Sure. Yeah, thank you. So in order for us to be compliant with the IEEE isolation requirement, as well as other parameters, and the IEC safety, we had to abandon the AC coupling capacitors that were rated. You see them here and there, 50 volt, 2 kilovolt. Those approaches are not satisfying what the standards are calling for. Instead, we are adapting to this discrete filtering, what we refer to. We can achieve the high isolation in a very small package with that LAN transformer and accommodate the common mode choke to satisfy all the requirements from the IEEE standard, as well as the safety requirements by the IEC. The first schematic top left side, that is showing the whole signal chain from your connector all the way to the PHY. It's consisted of VSD protection, the LAN transformer, balancing capacitor there, and some RC or similar to Bob Smith termination jelly beans around. Now, if we add to the mix the poodle inductor, the coupled inductor, which is shown in the bottom left side, that is pretty much all you need in terms of discrete filtering to implement the SPE. That is presented also in a 3D PCB there, so we can see what the size of the complete solution in discrete world is. For reference, that coupled inductor is 1090 millimeters package.
Perfect. And Fiona, same question to you. What are your current capabilities based on what you've shared so far, and anything else you'd like to touch on?
Yes, so I guess in EDL we have a number of different products available they're all available through analog.com. You can order them on analog.com or through any of our distribution partners, which I know we all share here on the call. So people like arrow.com, Mauser, and DigiKey. So we have a portfolio of solutions, and we've tried to tailor those solutions very specifically to some of those different applications that we talked about today. So we have a PHY, which is our ADIN 1100. That's available for over a year, and we've been sampling it actually for over about 2 to 3 years. So we have lots of customers up and running in that. And that's really, compliant to the standard 802.3cg, fully tested, fully specified, very low power, and really ideal for a number of those field instrument sockets or some of the, flow meter type technology where people want to use higher power processors. To optimize at a system level, then we have for the field devices are those constrained nodes that we talked about. So field instruments, pressure transmitters, temperature transmitters, we have the MAC5. So that's optimizing at a system level for power with the SPI interface. And that's the ADIN 1110. Again, that's fully released and available. And then we have just at Christmas there taken to the market our newest solution, which is our ADIN 211. And this is actually targeting line and ring topologies where, you want to connect devices in a ring or a daisy chain network, and particularly where you're replacing something like RS485 or a multi-drop network. And we've seen this being very popular in building automation applications, or even in some of those constrained cabinet applications that you talked about at the start, where you can, daisy chain lots of nodes together. So that's the ADIN 2111, and that's available again through our distribution partners for samples or through analog.com. It has, again, the SPI interface, so it's really enabling those low power processors at a system level. It's very low power, you're talking about less than 80 milliwatts. And it's ideal for constrained edge devices where you want really small housing, and the aesthetics of that housing is important, like buildings. So I know you can't kind of see behind me, but often we see those little temp sensors or, gas sensors in buildings. And as we automate out our buildings, because 40% of our energy is actually consumed within buildings. If we want to reduce our carbon footprint, we have to start there. And single pair Ethernet is going to play a huge role in that, as is the ADIN 211. So I think that's some examples of some of the solutions we have to offer.
We're going to quickly bring up two more examples because we have the visuals for
boards.
that we're really excited about. So tell everybody what this is.
Yes, so I guess we have a couple of boards to help our customers get up and running, because we know working with Harting and Fort, we understood that a lot of customers didn't, the ecosystem wasn't out there like the field switches, and people to test 10-base T1L or single pair Ethernet systems, they needed to connect back to test rigs that were RJ45 based.
Yep.
So we created media converter boards, so to convert between 10-base T1L and 10-base TE, right? Standard. And this board is an example of one of these. We actually have the Harting footprint on there, so you can connect some of those Harting connectors. And this is just a standard eval board. It has the PHYs, and you can get a version with the MAC5. You can connect with RJ45 and standard Ethernet in, and you can get single pair Ethernet out. And then we have another example where we took this to the next level. And I don't know if you have the other example to show as well. So this is where we worked with Harting and actually Arrow and InfoChips to actually maybe move that board into something slightly more easier to use. And it's again a media converter. You can have your RJ45 in, you can have your single pair Ethernet connector from Harting out, or you can have screw terminals. And it's again it's enabling customers to develop test rigs. So a lot of what we saw is for net load robustness testing of the network, they had to connect to these CFOS testers, which were RJ45, and they actually had to stack loads channels. So these can be actually stacked beside each other, on top of each other. For people developing firmware on SPE solutions, they needed to convert back, connect to their PC with standard RJ45. So there was lots and lots of use cases, and this is just a really handy tool. It's available from our.com. And you can go online and register your interest, and they'll be available very shortly. But it's a tool to help our customers get up and running, help them with their testing, help them with their product setup, and just get to market fast, which we want all of our customers to be able to do to help build out this network.
Yeah, it's just really exciting. We definitely wanted to highlight this. Going back to what Fareed had talked about of the components that you need, and we've all kind of talked about the components that we have available. For any audience members that joined yesterday, that was led by my colleague Arnold. He has a great term for this, which is called the minimum viable ecosystem. And that's exactly what you're looking at. If you wanted to start right now today, you could design a single pair Ethernet system using the two products that were just shown, in addition to all of the products that we've shown up to this point. I want to bring that picture back up just 1 second, because I want to highlight exactly what we're talking about, just to make sure that it's crystal clear. So you have your standard RJ45 here. So that means that anything that is communicating Ethernet over standard RJ45 today is adaptable to this media converter. And then just, we're so exponentially proud of this. You can see IEC 63171-6 over here with the T1 industrial. It says 10-base T1L. And this next version is the one that has everything connected together. So this is exactly what you'd be looking at if you purchase one of these to begin your single pair Ethernet development, your RJ45 going in on the far end there, and then you're connecting to the 63171-6T1 industrial on this side, and then eventually going to whatever you're beginning to implement using single pair Ethernet technology. So we just wanted to show you this, really highlight it, make sure that it was crystal clear, because I know on behalf of Harding that we're extremely proud of this, and to be working with Arrow and ADI on it, it was an incredible achievement.
Yeah, and it comes complete with, so the cable assembly comes with it, so customers can get up and running really quickly. So the cable assemblies come as well. So it really is a path to fast prototyping.
So we are going to now move into the second panel discussion. So we're going to cut away just for one moment when we bring in our new panelists, and then we'll be back with you in just one moment. All right. So before I introduce our two new panelists, I just want to extend a thank you once again to Fareed and Fiona. We're going to be hearing back from them at the end of the presentation for the live question and answers. I want to remind everyone that based on anything that you've seen up to this point or anything that you will see in this panel discussion, make sure that you're putting questions in the Q&A portion of this live broadcast, and we'll be addressing them at the end. But I want to introduce Vivek as well as Mason, and I will kick it over to both of you to give your own full introduction.
Yeah, so thank you very much, Mackenzie. So I'm Vivek Dave. I'm the head of the Innovation Hub for Harding in Cambridge, Mass. And the whole purpose of the Innovation Hub is to work very closely with customers and co-create new innovative solutions. And certainly this whole area of Industrial Ethernet and SPE is very high interest to our customers and to the Harding Innovation Hub.
I'll go next. Hello, everyone. I'm Mason Kahn. So I'm really concerned about solving customer outcomes when it comes to industrial cabinets, and we're going to enable smart decisions to increase productivity and yield for the customers using the single pair Ethernet technologies, namely T1S, which we will discuss a bit later in detail. I work at Rockwell Automation. I'm based out of Milwaukee.
Great. So Mason, we're actually going to stick with you for a moment because we've shown and explained some parts of APL. I showed general purpose as well as hybrid. There was another pillar there at the beginning of the presentation, which was resource constrained. Rockwell Automation is very involved in this portion of single pair Ethernet. So we want to kick it over to you just to give an introduction in general as well as in detail of what Rockwell's doing with Ethernet and single pair Ethernet.
Certainly. I'm going to actually take a visual approach to answering this. First, we have to look at what are the actual applications. So on the screen, you're seeing a general representation of an industrial control cabinet. If you were to go to a factory and open a enclosure or a panel in front of you, you might see things like the ones you're seeing on your screen. You may see switches on the door. These are the devices that we interact with to start a motor or stop a motor. Sometimes we are kind of reversing the direction of the conveyor, like going from forward direction to reverse direction. That's kind of usually on the panel door, right? And in the panel, you will see the motor control apparatus. This is going to be circuit protection devices. This is going to be the actual contactors or the switches that make the motor connectivity. And then you have the overload devices that are responsible for making sure that the conveyors or the material handling equipment is not going into overload. And there's tons of other essential infrastructure, from power supplies to relays to switches, that goes inside these cabinets that you're seeing on the screen. So generally speaking, it takes a lot of effort to build a panel as you see today. There is tons of wires needed for a motor starter. Just for example, if you're making a unidirectional motor starter, you have something close to 8 or 13 wires that you need to terminate from point A to point B. If you're controlling the direction of the motor to go in both ways, forward and reverse, you would have up to 22 wires. Now imagine a panel where you have maybe a dozen motor starters, or even you have 100. You have thousands of wires. So that's really a lot of potential for miswire. a lot of potential for in the field if a wire would come loose due to vibration or some other factors, and talk about troubleshooting a panel if you were to have one of those wires misplaced, right? So for us, T1S is a way to eliminate the wires in the cabinet. Now, this is a major dimension of the T1S use case for us, because up till now, you've heard all about connectivity. And yes, connectivity is a big part of it. We are enabling all of those switches to have connectivity to the controller, which was not possible in the past because these devices are constrained, meaning they don't have the density or the size capability or even the power to do that. So I'm going to just stop here and see what questions might arise from this intro.
Not really a question, but I'd like to highlight the point that by doing what, the route that Rockwell is going down, the elimination of potentially 22 wires, which are done by hand when these cabinets are assembled, is just a huge benefit, both from manufacturing it in a facility, like Rockwell does, as well as manufacturing it out in the field. A lot of these motor starters and contactors are added or removed depending on needs changing over time. And being able to do this is just an incredible feat, as well as bringing them onto an industrial Ethernet network for the first time and using, we were talking earlier about data harvesting, and being able to capture data down to the level that we're doing now is just truly incredible. I kind of would like to hear from Vivek, maybe not specifically around this application, but the current state of Ethernet development and where all this is going. And you work within the Innovation Hub. Some people might not know what that is. So if you want to give a brief introduction, that would be fantastic.
Yeah, no, my pleasure. And it's a very good question. So first of all, I'll just say a little bit about the Innovation Hub. What we try to do is work with early adopter customers, with customers to co-create technologies and solutions going from what's called a TRL3 level to a TRL6. So TRL3, I have a working prototype in a lab environment, but I have no idea whether it'll work in a real industrial environment. And so we take that and we de-risk it, hand in hand with the customer to get to a viable TRL6 demonstration, which is I have an industrial prototype which works in a relevant end-use environment. And so with that in mind, let's go back to the discussion of Ethernet-based technologies in general, and then SPE more specifically. So yeah, I think, we've already discussed over the last couple of days, I think, some of the global drivers for the adoption of Ethernet technologies, the fact that the expertise available to even implement traditional field level connectivity is rapidly fading. And really the huge advantage to exploring these other use cases that are outside the narrow domain of specific automation and control tasks. Mm-hmm. For example, all the sensor data you might want to gather regarding the state of the building, the state of the machinery, predictive maintenance, things that go beyond the real-time control domain. And this is really best enabled by Ethernet-based technologies. And then if we look at SPE specifically, I think, one of the key advantages that's already been discussed is, the long distance. And the ability to, very rapidly access nodes, sort of the low marginal cost of adding additional sensing, as opposed to traditional techniques, that's a very strong driver. And one area that we see a lot of growth, for example, is in logistics, intralogistics, conveyor systems, warehouse automation, and especially during the pandemic, there's been a whole, rethinking about how people order things, and
sure,
for a facility like an Amazon warehouse to go down even for an hour would represent, potentially millions of dollars of lost revenue. So now, people are really thinking much more about predictive maintenance and diagnostics. The other thing I'd like to mention, it's not necessarily all about sensor to cloud. And there's a lot of innovation going on right now in terms of smart devices, edge computing. In some areas, such as semiconductor and automotive, they're very nervous to let their data go to the cloud. And so
Sure. Yeah.
they do a lot of on-premises, computing. And a lot of that could also be enabled, significantly by Ethernet-based technology, but then more specifically SPE as well.
Yeah, absolutely. I think we have another graphic, a different take on the industrial communication pyramid that I want to bring up here to send it back to Mason to kind of talk through his thoughts as we continue down. Like, this is the current state of Ethernet versus the future state.
Absolutely, yes. Today, if you were to look at a factory or a customer side, you will see you have the enterprise layers are well connected to the control layers and also higher value assets. These are things like drives or smart motor controllers or HMIs and so on and so forth. However, there is a gap. If you look at the very edge of a factory, you often will see that the sensory devices or the sensors are not connected. When I talked earlier about those push buttons or the switches, or just the simple motor control infrastructure, this is not connected to the higher layers of control. And that's a clear gap in the standard Ethernet. And the gap is there because these devices, the simple devices, are not able to utilize the full benefits of the Ethernet due to constraints. And this is often in the cost, size, and power. Like, if you were to look at the push button, it's like about GSML, it's like 1 inch by 1 inch, and you're not able to put the traditional Ethernet onto it. Therefore, there was a need to have a single pair Ethernet or a simplified version of it that can fit the size of those devices closer to the edge, yet they're able to deliver the same connectivity protocol. So that's kind of what we're showing in the pyramid to the right, that with single pair Ethernet, T1S variant in the cabinets, you're able to have the same language throughout the industrial floor and your enterprise layers.
Yeah, and going back to a point that I had made a little bit earlier, just the opportunity that's there for, what are considered legacy or brownfield applications, maybe machines that have been installed and operational for decades, where the functionality has been there to implement sensor technology and start gathering data from these machines. That's been there. But has it been cost effective to do that up to this point? I think it depends on a case by case basis where that individual plant is at. But through the use of this new technology, and specifically 10-base T1L, we're unlocking a whole host of capabilities to really, I think, for the first time, realize IIoT. I've been in this industry for about 10 years now. We've always heard about this, like IIoT, the connected enterprise, everything talking, the merging of IT and OT, as Fiona brought up earlier. We're still not fully integrated there yet. And I remain very bullish and hopeful that SPE technology is going to do that we're finally going to see maybe some of the things that we've been seeing in the commercial market, in the industrial market, because it's become cost effective to do so.
Yes, I think you're absolutely right. In fact, if you look at the landscape in the factory automation or industrial automation, only 20% of the factories are connected today.
Wow.
There is a lot of opportunity. And I think earlier you mentioned that there were cost constraints, that it's difficult to deploy a protocol from top to bottom. With single pair Ethernet, it offers a lot of disruption in terms of the cost effectiveness. You're able to deploy this technology at a fraction of the cost as before. And yet you're able to get all of the outcomes that will help you make the smart decisions in terms of increasing your productivity, increasing your yield, and anomaly detection, and just helping you schedule the predictive maintenance or predictive downtimes. Absolutely. Rather than having the machine coming to a halt and losing production, like Vivek was saying. It's very difficult, if you have a logistics and it's coming to a full halt, you're losing a lot of dollars.
Coming to a full halt and you have no idea why is even worse. If you're able to narrow it down to a certain, subset of factors, that's even an exponential improvement for unplanned outages. Those are still going to happen. We have to do everything that we can do to mitigate it, but even having a place to start will be so much more helpful for legacy applications. We have a couple more topics, so I want to quickly shift into those ones, but Vivek, this is kind of a question back to you. In terms of advancements of Ethernet technology, what else is being done? What else could be done? It could be single pair Ethernet specific or outside of single pair Ethernet. Like, what else can we do?
Yeah, so I think, we're sort of at the early stages of single pair Ethernet adoption. And although, you had shown a very potentially aggressive and optimistic, market outlook, which is encouraging. I think some of the main barriers may be just, hey, I've been doing this 0 to 10 volt, 4 to 20 milliamp forever. Now I have to reconfigure it to this new protocol. So there's some of that resistance. And to the extent that we can make that easier, I think you had shown some of those, adapters that could go, for example, from 0 to 10 volt and directly go to SPE.
Yep.
I mean, sort of as an interim measure, right? Until more and more device manufacturers sort of embrace, the concept and design it in, from day one. So certainly those things will help. I think, some really big early adopter customers and use cases that could really drive the technology forward. And people could very tangibly see that by doing this, all the promises were validated, and in fact, all the expectations were met. That would be really, a big step forward. And I think, we are seeing some of those. And again, not to dwell too much on the warehouse example, but I think in many ways they could be leading just because, of the tremendous upheaval that's occurred in the last 2 years, and really rethinking and reconfiguring their entire global operations. From logistics, and that has imposed tremendous new requirements. And also back to manufacturing, I think you had brought up a point earlier that some factories may have to reconfigure maybe even annually. And obviously using Ethernet-based technology is the right way to go. That would be a nightmare using any kind of traditional field bus technology. One of our customers, for example, recently reconfigured a factory in Michigan to go from an engine plant to an EV final assembly plant.
Yeah.
You want to talk about a huge transformation, and you're going to increasingly see those kinds of needs, in the future. In fact, there are production systems coming online now that are sort of what I call, hyperscale in terms of their huge product mix and also high volume. So you could potentially have in one production cell, any one of 100,000 potential part numbers made in any sort of arbitrary sequence in any sort of arbitrary volume. And, there's no way you could do that with traditional, field bus type technology. It's just unimaginable. And so I think there are a lot of these global sort of underlying drivers, the way manufacturing has changed, the way logistics and conveyor systems and warehousing and everything has changed, that is really going to be promising, I think, for the adoption of Ethernet-based technologies.
Sure.
Vivek, give me some really interesting points. I'm going to just comment on briefly on one of them. I think what we have seen is that throughout the pandemic, like you mentioned, the logistics and the manufacturing industry, we are known for our speed, right? Industrial sector is usually the slowest one to adapt new technologies. Consumer and the commercial markets are much faster. That's kind of just a given fact. But what we have seen during the pandemic or aftermath of the pandemic is that there is a bit of step change to adopt more of the modern technologies such as single pair Ethernet. And I think that's going to lead to a lot of new infrastructures and new optimizations and growth, really.
Mm-hmm.
Yeah, and a couple points that you both made. Firstly, Vivek, you were talking about this as kind of like an interim step when you're especially looking at hybrid. That's what I'm most excited about, is that, for the most part, out of the box, you have a ready single pair Ethernet solution that adapts to products that are on shelves and in plants today. Because we need those interim steps. Like, we're at the very, very beginning of this adoption curve, and we need, number one, interim steps, and we need, number two, early adopters. And, I think everyone that's on this panel, on both panels today, is an early adopter and very excited about this technology. But that's how we get where we're trying to go. And Mason, to your point about kind of being a laggard in terms of the commercial market, we also have to adapt to the way that consumers buy things, both coming out of the pandemic. We fully shifted to at first it was what can we get and how fast can I get it? And then number two, it very quickly shifted into, well, I'm not doing all that much, so I'm going to be more selective of what I choose to spend my money on. And I heard about this recently in a different conversation, that there's a belief that we're moving into a model where we all have kind of been immersed in this culture where there's only a few options of things. And Vivek, I think this goes to, you know, your statistic about needing hundreds of thousands of different products now, where, you know, even in a grocery store, there's only a certain amount of types of Coca-Cola, for example. And I think that we're shifting into a time where we have to adapt to the consumer being able to want to buy exactly what they want, like a subset of, you know, maybe there was only 5 products and maybe there's going to be 25 products now that are extremely specific and extremely niche, but big enough to where we have to respond to what the market wants. And because of all these factors, manufacturing is going to have to continue to be more lean, more reactive to what their consumers are asking for. And again, you know, a lot of people, I don't think, can visualize what reorienting your plant maybe every year like looks like that seems very, very foreign, I think, to all of us. But I think that's where we're going, and we have to be ready for that. Our products have to be ready for it.
Yeah, no, you're absolutely right. And just again, think about the user experience as well. Okay, as consumers, we're used to outstanding user experience. You know, I order something on, you know, again, just to pick on Amazon for now, I order something on Amazon, it shows up the next day. And it's exactly what I want, and it's exactly when I want it. Now go to the industrial space. Is that possible today? Probably not. And so now imagine, you know, the next level of customer or user experience where, again, let's just pick on connectors for a while. I have a digital tool which completely allows me to configure any connector. Even higher than that, I have maybe an ML AI expert advisor which tells me, what are you trying to accomplish? Okay, sure. Now this is probably the subset of products you need to be looking at. And by the way, allow us to automatically configure it for you. And now that has to get translated to something which can automatically generate, you know, a work order within the system and automatically produce that component. And it comes out in a box, you know, in a factory in North America, in Europe, wherever, probably in the region for the region would be even better.
Yeah.
And so this is what sort of the next generation of even engineers are going to expect from industrial companies, you know, that same level of convenience that they experience in their private life or their, you know, their other aspects of their life, you know, as consumers. So I think that that's going to be a reality for many different industrial products.
Fully agree. Okay, we're going to move into our question and answer portion here. So we're going to take just a very short break. We're going to bring Casey back in the room to moderate the discussion, and we're going to have all 4 panelists. So I'm really excited about this conversation. We'll be back shortly. Hey everyone, this is Mackenzie Reed from Harding. We unfortunately had a power surge in our building today during the question and answer portion of our live discussion during the Industrial Ethernet Week. We are going to reschedule this portion of the session with all of the panelists, where we're going to address your questions that came in today, and you'll also have the opportunity to ask additional questions as we're talking through them in this new session. It's going to be a fireside chat with all the panelists that joined today, so keep an eye out for a future date and time for that to be scheduled. I wanted to say thank you to all of our panelists as well as all of our attendees for joining the session today. If you have any specific questions between now and the fireside chat, feel free to reach out to us, and we look forward to this next session soon.